Our first question is, which two deployment types support high availability? So to answer this, let's first take a look at our second question is, which protocol establishes network redundancy in a switched firepower device deployment? Let's look at some concept to answer this question. Hello everyone, and welcome to today's online class presented by 591lab.com. This is Cisco Certified Network Professional Security, securing networks with Cisco Firepower, which we call as SNCF 300-710. First of all, let me tell you more about 591 Lab. 591lab.com, pronounced as 591 Lab, is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today, we will be covering firepower modes of operation and firepower deployment from the securing networks with Cisco Firepower exam objectives. These concepts will help prepare you for the securing networks with Cisco Firepower certification exam. Quickly, let's deep dive into our first question. So, our first question is, which two deployment types support high availability? So to answer this, let's first take a look at firepower design deployment. The first mode of operations that we are going to look at is routed mode. Routed mode is the most traditional mode of operation for a firewall. In routed mode, the firepower device acts as a layer 3 router, which means it can route traffic between different network based on their IP address. Two or more interfaces in routed mode will typically have two or more physical interfaces. One interface will be connected to the internal network, and another interface will be connected to the external network, like the internet. The firepower device will route traffic between these interfaces based on the configured routing protocols and policies. Firepower devices in routed mode can also perform network address translation. Network address translation is a process that translates IP addresses from one network to another. This can be useful for a number of reasons, such as conserving public IP addresses or hiding the internal IP addresses of your network from the internet. Firepower devices in routed mode can also support dynamic routing protocol. Dynamic routing protocols allow routers to exchange routing information with each other automatically. This can help to ensure that the routing table on the firepower device is always up to date. Now, Let's look at the benefits of routed mode. The first benefit is consolidated functionality. Routed mode allows you to consolidate the functionality of a firewall and a router into a single device. This can simplify your network design and reduce your hardware cost. The second benefit is centralized security policy management. You can centrally manage your security policies on the Firepower device. This can make it easier to ensure that all of your devices are protected by the same security policies. The third benefit is scalability. Routed mode can be scaled to support large networks. Firepower devices in routed mode can handle a high volume of traffic. Then we have transparent mode. In transparent mode, the Firepower device acts as a layer 2 bridge, which means it operates at the data link layer of the OSI model. A bridge operates by examining the media access control addresses in the data packets it receives. Transparent firewall do not route traffic based on IP address. When the Firepower device in transparent mode receives a data packet, it examines the destination MAC address in the packet header. If the destination MAC address is on the same network segment as the Firepower device, the packet is forwarded out of the appropriate interface. If the destination MAC address is on a different network segment, the packet is dropped. Let's look at some of the benefits of the transparent mode. The first benefit is easy to use. Transparent mode is easier to deploy than routed mode because it does not require any changes to the network IP addressing scheme. This can be a significant advantage for existing networks. The second one is security transparency. Because the Firepower device is invisible to traffic in transparent mode, it can provide a layer of security without disrupting the normal operation of the network. This can be useful for deployments where it is important to minimize the impact of security measures on network performance. Transparent mode is a good option for organizations that need a simple and easy to deploy security solution. Transparent mode can be a good option for organizations that are concerned about the impact of security measures on network performance. When deciding whether to use transparent mode, it is important to consider the security requirements of your network. Transparent mode may not be suitable for all networks. Let's take a look at how routing is performed on Firepower Threat Defense. Firepower Threat Defense performs L3 route lookup as part of its normal packet processing flow. This means that Firepower Threat Defense can route packets between different networks. Firepower Threat Defense is optimized as a flow-based inspection device. This means that Firepower Threat Defense is a good at inspecting traffic for security threats. But it may not be the best choice for routing large amount of traffic. For smaller deployments, Firepower Threat Defense is perfectly acceptable as the router. If you have a small network within a few devices, Firepower Threat Defense can handle the routing duties without any problem. For larger deployments, a dedicated router is a much better option. Dedicated routers are designed for routing large amounts of traffic, and they can provide a better performance and scalability than Firepower Threat Defense. For SD-WAN, Viptela is much better option. SD-WAN stands for Software Defined Wide Area Network. Viptela is a company that sells SD-WAN solutions. SD-WAN solutions can help you to optimize your WAN connectivity by using multiple links from different carriers. Firepower Threat Defense may originate routes depending on the network design. In some cases, Firepower Threat Defense may need to originate routes in order to communicate with other devices on the network. Let's take a look at static routing. Manually configured routes that specify how packets should be forwarded to reach specific networks. Static routes are useful for small networks or for configuring a default route to the internet service provider. Now, let's look at the interior gateway protocols. Routing protocols used within a single autonomous system to share routing information between network devices. FTD supports the following interior gateway protocols. The first one is OSPF, which is also known as Open Shortest Path First, a popular interior gateway protocol that uses a link state routing algorithm to calculate the shortest path to a destination network. FTD supports OSPF v2 for IPv4 networks and OSPF v3 for IPv6 networks. Routing Information Protocol, which is also known as RIP, a simple and easy to configure interior gateway protocol that uses a distance vector routing algorithm. FTD supports RIP version 1 and RIP version 2. The next one is EIGRP, which is also known as Enhanced Interior Gateway Routing Protocol, a Cisco proprietary interior gateway protocol that offers several advantages over routing information protocol, such as faster convergence time and loop prevention. The next one is BGP, also known as Border Gateway Protocol, a routing protocol used between different autonomous systems to exchange routing information across the internet. Firepower Threat Defense supports BGP4 with IPv4 and BGP6 with IPv6 addressing. Multicast is our last one, a specialized routing protocol for sending data to a group of devices simultaneously. Firepower Threat Defense supports multicast routing. The last one is policy-based routing, a mechanism for controlling the routing of traffic based on policies. Firepower Threat Defense supports policy-based routing, which can be used to route traffic based on factors such as source IP address, destination IP address, or application protocol. Hence, the answer for the question, which two deployment types support high availability, is transparent mode and a routed mode. Why transparent mode? Because in this mode, a device acts as a layer 2 bridge, forwarding traffic seamlessly without modifying packets. If the primary device fails, a secondary device in standby mode can quickly take over, maintaining traffic flow with minimal disruption. The routed mode because the device operates as a layer 3 router, managing IP addresses and routing decisions. Similar to transparent mode, high availability can be achieved by having a standby device ready to assume routing duties if the primary one fails. Now let's look at why other options are incorrect. The option C, clustered. While clustering can improve performance and scalability, it doesn't directly guarantee high availability. A cluster failure might still lead to service downtime. Option D, intra-chassis multi-instance. This option refers to running multiple instances of a system on a single physical chassis. While it can offer some redundancy within the chassis, a hardware failure on the chassis itself can bring down all the instances. For example, FPR 400 and 9300 series. Option E, virtual appliance in public cloud. Public cloud deployments offer various features that can contribute to high availability, but the deployment type itself doesn't guarantee it. Cloud providers often offer redundancy that needs to be specifically configured to achieve HA. Hence, the other three options are incorrect. Our second question is, which protocol establishes network redundancy in a switched firepower device deployment? Let's look at some concept to answer this question. The spanning tree protocol is a layer 2 protocol that is used to prevent loops in bridged networks. It works by electing a root bridge, which is the central bridge in the network. All other bridges then determine the best path to the root bridge. and block any ports that would create a loop. This ensures that there is only one active path between any two devices in the network. In a switched firepower deployment, spanning tree protocol is used to ensure that there is only one active path between the firepower devices and the rest of the network. This helps to prevent traffic from looping back on itself and causing network problems. In conclusion, spanning tree protocol is an important protocol for ensuring network redundancy in a switched firepower device deployment. By preventing loops, spanning tree protocol helps to keep traffic flowing smoothly and efficiently. Hence, the answer is A, spanning tree protocol. While HSRP, VRRP, and GLBP are all used for redundancy purposes, they focus on gateway redundancy at layer 3. They do not address establishing network path redundancy within a switched network, which is the primary concern for firepower devices. HSRP, VRRP, and GLBP creates a virtual router with a single IP address. They provide redundancy by allowing devices to seamlessly switch to the backup router if the primary router fails. Firepower devices, as security appliances, rely on a reliable and efficient network path for inspecting traffic. Spanning tree protocol ensures a loop-free, single active path that optimizes traffic flow for these inspections. HSRP, VRRP, and GLBP, while valuable for gateway redundancy, wouldn't directly address potential path failures within the switched network that could impact firepower functionality. Hence, the answer is spanning tree protocol. Thank you all for attending today's class at 591 Lab. We hope you found this material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day ahead.